Required to find the area of the red inscribed equilateral triangle. Let base angle of the right triangle be equals to alpha. The relationship of angle alpha to every angle of the right triangles are shown on the figure. Although, we will not use it to solve this problem, but to show you how to get this relationship in case you come across a question involving angle relationship. Alright, let us continue with our solution. Let x be the side length of the square and y be the opposite length of the base triangle. This means that let us find the hypotenuse of each of the right triangle using Pythagoras' theorem. Since the red triangle is equilateral triangle, we obtained an equation for the square root of the right triangles. This is because each of the side length of equilateral triangle are equal and each of its angle equals to 60 degrees. The equation shown on the screen. Equate the first and the second expressions and then square the equation, and we have the sum of the square of x and 16 to be equals to the sum of the square of y and 121. Rearrange terms, combine like terms and simplify, and we have that the square of x minus the square of y equals to 105. We call it equation 1. Also, equate the second and the third expressions. Square the equation, and we have that the sum of the square of y and 121 equals the sum of the square of x minus y and 49. Expand brackets. Rearrange terms, combine like terms and simplify, and we have that the square of x minus the product of 2 and x times y equals to 72. We call it equation 2. Now that we have obtained two equations in x and y as shown on the screen. From equation 2, we have that y equals the square of x minus 72 all divided by 2 times x. Substitute it in equation 1. Thus, we obtained an equation in x alone as shown on the screen. Expand bracket. Combine like terms and simplify. We have a quartic equation in x alone as shown on the screen. For simplicity, let u equals the square of x. This implies that the product of 3 and the square of u plus 144 times u minus 5184 all divided by 4 times u equals to 105. Cross, multiply, simplify, and we have a quadratic equation in u as shown on the screen. Combine like terms, simplify further, and we have the product of 3 and the square of u minus 276 times u minus 5184 equals to 0. Factorize. This implies that after factorization, that the product of the factors equals 0. Thus either u minus 108 equals 0 or u plus 16 equals to 0. Therefore, u equals 108 or u not equals to negative 16. It is because the length measuration cannot have a negative value. Recall that u equals the square of x. It implies that the square of x equals 108. Find the square root of the equation. X equals the square root of 108, which is equals to the product of 6 and the square root of 3. Consider only one side length of the equilateral triangle. Thus, we have the square root of the sum of the square of x and 16. Since the square of x equals 108, this implies that the sum of 108 and 16 equals 124. Hence, the area of equilateral triangle equals the product of the square root of the sum of the square of x and 16 and the sine 60 degrees all divided by 2. Substitute numerical values we obtained and our result equals the product of 31 and the square root of 3 in square centimeters. Therefore, the required area of the equilateral triangle equals the product of 31 and the square root of 3 in square centimeters, or 53.694 in square centimeters to 3 decimal places.